Hello, how's it going? In this video, we're going to apply textures. Let me just close these bits. First of all, I'm going to go to the shader and I'm going to set the shader up so that we are applying texture. Now see here, at the moment we're hard coding a color. Let's not do that. In my Vertex, I'm going to take in a texture coordinate. It's a two-dimensional float. There we go. So the position is attribute 0. The texture coordinate is attribute 1. And then we're going to pass that data along from the vertex shader to the fragment shader. So we'll put that in there. Now we do not have to put a what is this? A qualifier, a layout modifier, whatever. We don't need to put that there because we just simply don't need it. So what we can do is we can take the output and just code this in. The texture coordinate of the output is really just the texture coordinate of the inputs. We get the vertex in and access its texture coordinate. Okay. Now, at this point, I'm going to take a few things. Let me just rejig this a little bit. Yep, so we'll have the fragment structure that's coming in, and we'll also have a two-dimensional texture. So in the render encoder, when we set, set texture index 0, it's kind of like texture units in OpenGL. This is the texture object which is bound at index 0. Now this float is referring to the data type stored inside the texture. Each of the numbers, red, green, blue, alpha, whatever, is something between 0 and 1. It's floating point. And another way to think about it is we kind of want to stop thinking about textures as images. We want to start thinking about textures as arbitrary large chunks of data that we just ship off to the graphics card. For example, if I were to do a compute shader, which I don't know if Metal does compute shaders, but in OpenGL we can do compute shaders. And in those cases, we can send textures around to describe numbers of any sort. But I'm getting a little bit ahead of myself. So what I'm going to do is right now I'm going to make a sampler object. I'm literally going to call it a sampler object. And what we can do here, sample the object texture. So go sample, we put in the sampler object and the texture coordinate. And that should be it. I feel like this needs to be instantiated. Okay. Guess not. All right, let's go with that. That's fine. Okay, so we've got that. The next thing we need to do is we've declared that our meshes are going to have two attributes now. So let's go to the mesh class and update that. So we'll go to object mesh, and here we're declaring attribute 0. Now we'll declare attribute 1. And attribute 1 is the texture coordinate. Yep, that will be two numbers, S and T. The offset will just keep, this is just incrementing all the time, so that's fine, that's handled for us. This will be bound to buffer 0, okay? And then we just increment that according to the stride of a vec2. Okay, now we only need one layout because a layout has attributes. Mesh descriptor, this is fine, I guess. And we're going to just set the named attributes in here. So we'll copy that code. And this will be model vertex attribute texture coordinate. Okay. So that, I think that's okay. Let's just test this. So if we run this, it's good to run it now and then just to check if it works or not. Oh, I just saw a problem. I wonder if this runs. Anyway, it shouldn't run because what we should do is that should be 1. What's it doing? Yeah, that's messed up. Okay, let's try that again. Okay, cool. So, yep, we haven't sent in a texture to bind. That makes sense. So the next thing we'll need to do is we will need to create a material class to describe the texture, and then we'll bind that in and render it. Also, I'm noting the camera, it's just looking a little too close for my liking, so I'll just bring it back a little bit. I'll go to the scene, and where are we? We're at an x of -1. Let's make it an x of -3. Okay, but anyway, that should be fine. So now I know I am clashing a little bit with, this isn't the most Swiftastic way to do it, I'll say that. Putting my mesh and material classes in view, even though they're technically not the SwiftUI view sort of concept, but that's fine. Yep, so I'll call this material.swift. That is great, and this is actually going to be pretty similar to the object mesh. So I will just grab all of the object mesh code. And when I say pretty similar, it's actually not similar at all. I'm just too lazy to write a simple class. That's fine. There we have it. So the class is going to be called material, and we will have, the material will have a texture object, which will be a metal texture. Okay. And let's go to the initializer. So the same way that a buffer, Vertex buffer, has a buffer allocator, there is something called a metal a metal kit texture loader. Okay, file name, that's fine. We'll call this material URL. File name. Oh, by the way, let me just bring this up. If I go in here, there's this arty.jpg. Looks reasonably arty. I'll just kind of drag that into my project. Okay. So I want to end this in .jpg. Okay. I'm not going to worry with any of this stuff, so I'll just go down. What do we have here? Okay. So this is the point where I'm going to load my texture. So I'll go texture. I'll take that allocator. Yeah, make new texture, and the URL will be that material URL. Just give it a second to check all the... Yep, okay, that seems fine. Okay, so far so good. Now I will pop to the renderer, and I'll say, all right, do your thing. It's probably going to be loading many materials, and we could create a different texture loader each time, but why not simply create the one texture loader and reuse it, same as we did with the allocator. So we'll go let material loader and that'll be a metal kit texture loader. If I could spell. Okay. And then down here we have a bunch of things. We have the scene, the mesh, and I'll just go material. I know I'm going to come up with more imaginative names later on, but this works for now. So here we're making self allocator. We'll also make self material loader. Okay, and this takes a device. Okay, so we need device, allocator, and file name. For the device, we'll pass in our metal device. For the allocator, that will be our material loader, and the file name. Okay, fingers crossed, that should be working fine. So then what we'll do is we will go down to the draw. What do we have? Here we're setting the vertex buffer, so we're binding the mesh to draw. Now let's bind the texture. Okay, so here it was set vertex buffer, so we'll go set fragment texture. The texture will be our, what is it? Material texture. And the index is the texture unit that we're drawing to. So there's a certain number of textures that we can bind together and draw in one call. This will be index 0. Okay, fingers crossed, let's just see what happens. Right, we've got it. It's a little messed up. This is too arty even for me. Now the issue is that we have not got any depth buffer or depth testing. And so the faces, the triangles, are drawn in the order they're defined, irrespective of their depth. So we're going to have to sort of set this up. I'm going to step back a little bit. So we'll go to, again, look through this from the top view. We go to the project app. The project app produces an app view. And then the app view gets a content view. And the content view is the wrapper around the actual renderer. So we go into the content view, and we've got all of these things. So here we're setting everything about our metal kit view. I'm going to set the depth stencil pixel format. What is it? It was, yeah, depth 32 float. That's a good one. Okay, that's great. We also need to set that in the renderer. So up above we have pipeline state. Okay, I'm also going to have a depth stencil state object. Okay, and I'll configure that after I configure the pipeline, because I also need to configure some stuff. So I'll go pipeline descriptor. Yeah, depth attachment pixel format will be the same. Depth 32 float, that's great. Okay, and then I will set up the depth stencil. So I'll go depth stencil. So hopefully you're sort of seeing a pattern here. Every time we go to create something, we create an intermediate object called a descriptor. And the descriptor has a bunch of fields which we can set. And it's basically like a structure that holds a bunch of data. And then we pass that descriptor over to a constructor, and that is used. Okay, so what do I want? I want the depth compare function to be less. So fragments which are at a lesser depth are kept, and fragments which are at a further depth then something already in the buffer are discarded. Let me step through that again. So when we render a fragment, we might have something on the position that we're trying to render already. And if the thing that is coming in that we want to render is behind, then it's discarded. That's what depth testing is doing. Okay, so I also want to set the write enabled. And then I'll construct this. So I'll say depth stencil descriptor. No, not that. State. And I just pass this in. And there we go. That is constructed. What are we doing? We're going to unwrap that. Okay. So now we go down to the render encoder, set the pipeline state. Yes, great. And also set the depth stencil state. Okay, so there we have it. Our texture is coming through and it's displaying. It doesn't quite look right though. That looks messed up. It almost looks gory. Anyway, so what is the issue? Well, it has to do with color spaces. So here we have this texture data, and this texture data is in a, just thinking, is it sRGB or RGB? It's RGB, sorry. So RGB is a certain color curve which runs linearly from 0 to 1, but a lot of renderers will sort of compensate for the display's color response by putting a non-linear response on there, which sort of punishes the darker colors non-linearly, so it biases things down towards a darker color. It's actually not too bad to correct that. So what we can do is we can go to our material class, and then when we make the new texture, there is another field called options, and here we can define options. So let's go make options, and as we can see here, the type is an array of metal kit texture loader options, having any type. Oops. Having any type. And what I'll do is I'll just go, what is it? sRGB. False. What's a flash? Okay, great. So we'll take that and we'll just pass that into the constructor. And now when we run this, it looks a lot nicer. Maybe even brighter than what I had up before. Okay, so this is great. It's great, but there's just one little sticking point that I'm not, thrilled about, and it's the fact that in the shader, we are constructing our sampler object. This is sort of a bad idea. It would be better if we could take a sampler object in. And it's actually not too bad to do that. So what we can do is just get rid of this and instead take it as a parameter for our function. Great. So now what we need to do is we need to create a sampler and sort of bind that in. So if we go back to the material class, we've got a texture, and I'm also going to create a sampler. It's a sampler state. Okay. Now we can create that sampler. So we'll say go ahead and create that, and we'll populate its fields. So we can see all of these we can set. I'm going to set the address modes. We have a bunch of options. So this is saying when our texture coordinates go outside of the standard range 0 to 1, how do we handle that? I usually repeat. Repeat is nice, but there are other options like clamping to edge or clamping to border color and so on. But just for the S and T, we'll repeat both of those. Okay. Other options. So this is just the standard, like if you know OpenGL, the standard sort of stuff. From there, we have a minifying filter and a magnifying filter. For my minifying filter, I'm going to use the nearest. And for my magnifying filter, I'm going to use linear. And yeah, that's fine. That's looking nice. I don't think I really need to set these because the texture already looks okay, but this is just an example of how we would do that. And there are other options. But anyway, we need to create that sampler. So we'll go sampler equals device, make sampler state. And for the descriptor, we'll put in our sampler descriptor. And that's why I kept that device. Oh, what's going on here? Oh yeah, we just need to, unroll it. And that's why I kept my device hanging around as a function argument, because I was going to use it later to make the sampler. Okay, so what do we have it? Go back to the renderer, because we need to bind this in. Otherwise, we'll get an error. So we set the fragment vertex buffer. We set the fragment texture, and then let's set the fragment sampler state. So that will be the material sampler and index 0, because we're setting it up for sampler number 0. Okay, now we'll go ahead and run this. And it looks the same. I expected that, but we're getting no errors. It's working. Okay. Anyway, so I hope you enjoyed this session. Today we just sort of ran through textures. And yeah, I mean, these are the two big things for me. For me, it's meshes and materials. We have our engine. Our engine owns those assets, and it uses those assets along with data to describe scenes. Anyway, hope you had fun, and I will see you again soon. Bye.